Hi everyone, my name is Roman and I'm going to tell you something about progressive web apps and how you can create a web application using the PWAs or progressive web apps technology in DotVVM. Let's take a look at progressive web apps at first so that we know what we are talking about and that we know what progressive web apps actually are and what we need in order to get an application to use this technology. So if you have an existing website that you haven't optimized in any way, you haven't even thought of creating an application, but suddenly you have a need to create a mobile application, to create an Android application, iOS application, and to distribute them to your users. So what can you do? You can either start creating the application on its own, so you can use the technologies that are used for native development or for hybrid development, such as Cordova, or you can do something like React.js, and you can turn or create a completely new application. But this is not what we are going to talk about. We are going to talk about the scenario where you have an application, a web application that is optimized for mobile phones, so you are displaying it just right, but you haven't thought of creating the mobile application, or you don't want to invest into creating a separate application in a different technology that you don't know, or creating an application on its own. So we are going to take a look at progressive web apps that can help you to turn an existing application into an actual mobile application. You don't need to do the app development. That's what we're gonna talk about. There is only a little bit of work that you need to do, and you can have an application that people can install into their phones and use. It can work offline and online. We will take a look at some approaches to this and how we can achieve this. We are not talking about hybrid applications, just as I said, and we are going to use what we already have, so we don't need to think about creating the application before we started to do the website. It will have sort of a native experience, so if you design your website accordingly, if you design it as a mobile application with animations, with transitions, then you can achieve so that the user doesn't even realize that it's a website. It's going to have an easy installation. The user can install it either from a website, so from a mobile browser, or directly from the App Store or Google Play Store. It can support native device features such as running offline, such as accessing file storage, some sensors running in the background and providing notifications and such. And another thing that you gain by using this is discoverability, as you can create an actual application and distribute it through the stores. So you don't only need to send your users to the website and have them install it from the browser, but they can find your project in the App Store or Google Play Store and download it directly from there. First of all, the progressive web apps consist of basically two things. We're gonna talk about them. The first one is really easy, and so you can do it straight away, even for existing web application. The other one is a little bit more tricky, but we will take a look at how you can deal with it. The first one is something called Web App Manifest. It's a file that contains the metadata of your application. You link it in your HTML file, so you set where it's located in your file storage, and you put some properties in there. It's a JSON file, so you set it up so that it shows the browser stuff about your application. So it consists of things like the theme color that your application uses, so that's used in some scenarios for displaying the border and some colors in the application. It consists of icons that the application is supposed to use when you install it, the name of the application, either the short name or the longer name. You can specify both of them and they get used in different places. And the start URL where your site is supposed to launch when you run it. So when you run the application, which part of your site is it supposed to navigate to? There are other properties in there as well. This is not even the complete list. These are just the main properties that you can use that we have specified for the application, but you can use others as well. You can look into the specifications for web app manifest. So this is the really easy part. You just add one JSON file, specify your properties, and you have the basic of your application. The web browser will load this data and will let you know if you can even install the application. Some browsers work even just with this file, so you just need to input the manifest.json file, and the browser will be able to install the application and get the data from the file and set up the installed application accordingly. We'll take a look at it. The other part of this that we'll talk more about is the service worker. So this is a script that is running in the background and handles the requests that your application makes, so that your website asks for. And it's a separate script that runs apart from the actual web application. So this is a script that is running in the background. It has basically nothing to do with the application that is running, that is displayed in the mobile browser or as a separate application, but it handles a lot of stuff. So what's the main important thing is that it interferes with all the requests that your website makes. What this means is that if you think about what the website does, is it sends requests to the server. So usually it sends a request to the server and it gets a response from the server. So it can ask for a file, it can ask for some HTML file or an image, a JavaScript file or whatever, or it can send an actual REST request or something. What happens with the service worker is that the service worker runs on your device. So this is a script that runs directly on the device of your user where the application is installed. And the page asks for a certain thing. So for example, for an HTML file, the request doesn't go straight to the server. It goes to your service worker, and the service worker decides what to do. This is the most basic scenario where the service worker just sends the request to the server, it gets the response and provides it back to the browser. So this way basically nothing changes, but what's important is that this part is in there, that the service worker is interfering with all your requests. So we need to think about this. What more? What can you do with service workers? You can do caching. So you can do stuff that helps you with the speed of your website. You can cache some files, you can cache some responses to requests, and that can live on the device. So now when the user sends a request, or when the site, the browser sends a request, you don't need to call the server. You just reply with the cached response that is living on the device. So this way you can feel that you can finally function offline. So you see that this can help you even with optimization of your website, or even with running completely the website offline. So this way you can achieve an offline application. Apart from that, the service worker can do background syncing, so it can update the cache, for example, on the background, even while the user is not interacting with the application, even while the application is not actually running. It can handle push notifications, so this is the scenario where the application is off, the user doesn't have it even launched, and you need to send them a push notification. So in case of native applications that you install from the store, you have mechanisms that the application can receive the push notification, and it's registered somewhere in the operation system or in the notification center. With the web technologies, you need to handle this yourself. So your website has a service worker that is somewhere in the background, and it's waiting for a push notification to happen. So this way you can even send push notifications to a device that doesn't have the site running. So the user can receive push notifications just like from a regular app, and the service worker will handle this. What's important about the service worker is that it's a separate file, it's a separate script from the actual website. So it cannot access the DOM, it cannot access the actual site. So you can't rely on stuff that is in the document, and you can't rely on modifying, for example, some elements. You can't inject stuff into the body just willy-nilly. You need to think about this, that it's a separate script, it's not part of your website. It reacts to events. So as I said, it's something that runs in the background, but it doesn't really run all the time because it would just deplete the resources of your device, and that would be quite annoying. So the service worker is basically idle on the background, and it waits for an event to happen. The event can come from the browser, so it can come from an interaction from a user, and then it interferes the request and does something with it. Or it can come from the server as something as a push notification, and it can react to that and show the push notification either in the browser or as a system push notification. What's important is that you need to have HTTPS set up for your website. This is a requirement. It's because the service worker is basically interfering with all your requests. So if you have a script running on your device and you are doing a request, you don't want to have this running over HTTP, because you could easily get a man-in-the-middle attack from this, because someone could inject a script into your website and get this behavior and modify the requests that people send to your website, or modify the responses that they get. So this would be quite bad. So that's why there is a specification that all the PWAs, all the progressive web apps that want to get installed, need to run on HTTPS. So if you don't have your site running on HTTPS, come on, what are you doing? But you need this for progressive web apps. Let's see how you get the service worker registered. So as I said, it's a script. So it's a JavaScript file, and you need to register it somehow so that the website knows where the script lives, which part of the site is supposed to handle the request for this service worker, or the service worker is supposed to handle some part of your website. You can even do that. You can have different service workers for different parts of your application. So first, if you want to register it, you check if the service worker is actually supported on the browser that you're trying to register it on. This is the check that you run. Most of the currently supported or currently used browsers have support for service workers. So you have it in Chromium browsers, you have it in Firefox, you have it in Opera and Safari and so on. So you don't need to worry much about the service worker not being there, but there are definitely some browsers that didn't get updated that regularly that can lead you to have these as false, so you can't register the service worker in there. Then you can check if the service worker is already registered. So if this is not the first time that the user is visiting your site, and if the service worker hasn't changed in the background, so once it changes, you want to update it, but until it's changed, you want to have it running and you don't want the user to constantly update the service worker. So you can check it this way. And then you run the register script. So this way you say where the service worker is, where the file is located, and you set the scope which is supposed to be handled by the service worker. So these are the statements that you need to register service worker, basically. What about the life cycle of the service worker? So there are a couple of phases that it goes through. So let's see what they mean. In the installing phase, you can cache your assets. So this is the phase where the service worker is being installed. So it's not yet handling the request, but it's in the installing phase, so stuff is already happening. In this phase, you can set it to load the data that you want to cache on the device. So you can set it to load some images, some HTML files, and so on. Then when they get cached, it can use them in further requests to respond with the object from the cache. Then it gets to the activated phase, where the service worker is already installed, is handling the request, and this is the part where you want to handle your old caches. So if you are updating your website, if you are updating and launching a new service worker, and the previous one worked a different way, it handled caches differently, and there are some files cached on the user's device, you don't want these to just lay there and not being used. So once the service worker gets activated, you want to delete the old caches and manage them so that they get transferred to the new format if you are changing something. If you are not changing anything, you can just leave this as is. After this, the service worker gets to the idle phase. So it doesn't run, it doesn't deplete the resources of the device, and it just sits in the background and waits for something to happen. Now, something can happen, so there can be a fetch where you are processing a request, and this way the service worker gets awake and handles the request. So this is the part where it actually does something. Let's see what caching strategies we have or are basically supported. You could create your own one, but these are the ones that are already prepared and you can use them very easily. We'll take a look at how you set them up. So first of the caching strategies is called network only. This is not much of a caching strategy, as we will see. So how it behaves is that the page launches a request to the service worker sends the request to your web server and sends the response back. So not much caching happening here, but this is the strategy that can be used. We'll even see it in the code. So this is one that's frequently used, but we'll take a look at other ones. The cache-only strategy is quite similar to this one, just with one slight difference, that when the page launches the request to the service worker doesn't go to the server. It doesn't run the request to the actual server. It just takes a look in the cache, and if the file is there, it returns it. So this way, you can see that you are running offline. There is no communication with the server, which can be a good thing because your application is faster and you are not depleting the networking resources. But this can be a bad thing if the file or the resource that the page asked for isn't registered in there. So if it's not in the cache, then this won't work. Let's take a look at some more advanced strategies. Network first strategy, as it suggests, it sends a request to the service worker and it tries to do a request to the server. So network first, it goes over the network and it does the request. But the server is not found. There is some problem with the online state, so the device is either offline or it's on bad connection and it didn't get through. So then the fallback is to look into the cache. So first of all, the service worker tries to run the request to the server, but it fails. So then it takes a look in the cache and returns the file from the cache if it finds it there. The other case, which is again similar, but the other way around, is cache first. So in this case, the page again sends the request to the service worker. It first looks into the cache. If the file is not in the cache, so it's a file that you haven't cached, or is the cache expired or something, then it launches the network request and returns the response from the server. So this way you get the file first from the cache. If it's not there, you go for the fallback to the actual server. The last strategy that we're going to talk about, and that is widely supported, is something called stale while revalidate. This is where the page asks for a resource to the service worker and it looks to the cache and it returns. So far it looks like the cache only strategy, because the service worker took a look into the cache and returned the file from the cache. What happens after that is that the service worker in the background runs the actual request to the server. So for the file that you asked, it first returns it from the cache and then asks for the same file to the server and saves the current version to the cache. We'll see how this behaves in the following example. So we'll take a look at this. This has a lot of advantages because usually it makes your application faster, because you get the file served directly from the cache and it updates on the background. So there is not much risk of the file being outdated. But it doesn't save any network resources, because if you think of it, it serves the file from the cache, but it launches the request anyway. So this is not the same as the cache only approach, where it actually saved all the network resources. And we will see how this behaves. There is one slight issue with this. Let's take a look at the demo. So what we have in here is simple to-do application. So once I log in, the login is more of a filter, but let's say I logged in as a user. I get shown my stuff, so my to-do items that are in the database. So this is an application written in DotVVM that is running on a server, and it looks just like a normal web application. There is nothing specific about it. You can add a new item. So the site consists of 3 pages basically: the login page, the to-do items page, which is a list of all the items, and then a new item, so you can add a new one in there. There is not that much of stuff happening in here. What is important is how we handle the request and what's going on with the service workers and the manifest. So first of all, let's take a look at the Google console, or the DevTools console. Okay, I'm running it in Edge, so this is running on Chromium, but no Google here. The DevTools have a section dedicated for applications. So if you take a look at the section called application, you can see all the assets that are connected to the actual application. So there is the manifest file. You can see that there is already a manifest file uploaded for this application. So it's a manifest.json that has all the necessary properties that we need for the application to work and to get installed. You can see that there is a start URL, which is just the root of the website. There are some theme colors. We have set it to work in the portrait mode as a standalone application, and so on. So this is just the file that is getting served. if we take a look into the actual website, here is the link that sets which file is supposed to be used as the manifest file. Furthermore, there is the service workers part, where you can see that which service worker is installed. If it's running, you could see some errors if there were any in the background, and you can see what state of the service worker is currently happening, because it can be in all those phases. It can be in the installing phase, it can be in the idle phase, and so on. So you can see what's going on in here, and you can even unregister the script. If you open up this section with service workers from other origins, you can see all the websites that are actually using service workers. So even if you don't use service workers yourself, or your website doesn't use it, try to take a look at what websites you've visited that already have this technology, that are already working with service workers and are supporting your application in the background. So there can be stuff happening in the background if they are doing something. So these two tabs show you the stuff about your application that is installed. Let's take a look at the other stuff. Here is the storage. So this is the cache where all the files get stored. So this is where the service worker will look and ask for your files when you are offline, or when the request doesn't go through. Or if you have a strategy that's set to cache only, then it will always look in here. So let's try to erase some of the cache. Let's get rid of this part of the cache and set the site as offline and see what happens. I reloaded the website and got this nice site that tells me that your device is offline. I'll try to imagine this on a mobile device. We'll take a look at it on the mobile device later on. And this would look like your application has detected that the user is offline and show them some nice way of handling this. When I go back online and reload the page, now go back offline and reload it again, you will see that, oh, it didn't show the offline page again. If I go somewhere where I haven't yet visited, then I get the offline page. So we'll see which strategy we are using here in a minute. But you can see that it suddenly works. When I try to refresh the site, I get the content. It's offline, so the site is actually not running. And the user doesn't even need to know that this is happening. So let's see how this is done. Let's take a look into the Visual Studio. We have the project set up here. The link to the source code will be sent to you, or you can take a look at it. It's already on GitHub, so you can just download it and try it yourself. And let's take a look at what we have in here. So it's a DotVVM application, so we have a few views. There are 3 pages, just as I said. There is the login page, the list page for displaying the to-do items, and a new page that is for creating a new item. So not much exciting stuff happening here. The view models just as well, only 3 view models and the master page view model, of course. But let's take a look at the scripts. So what we have in here, in the www root folder, is a few service workers. We have different service workers in here, so that we could show how the service workers can be made. This is the most basic service worker that does only work with an offline page. So what this does is that it doesn't interfere with your request in any way. It just sends them to the server, But when it got installed in the installation phase, it registered and saved two files. So it saved the offline fallback page, which is an HTML file, and it saved the logo that is displayed on the offline page. So if I went back offline, so this image and the actual HTML. And when the request doesn't go through, so when something happens, it returns the offline page instead of the content that was supposed to be returned. So the website asks for this document, but it gets another document instead of it, which then it displays. These documents, of course, need to be prepared. So this is just a plain HTML file and an image. This is not some dynamic content that would need to be created on the go, because you want to have these prepared and ready to be cached and used offline. So this is the only part that is handmade and not using DotVVM for creation of the website. The other parts of the website are done dynamically using DotVVM. So this is an actual website. So furthermore, what we have in here, another service worker that could be used. And this one is the cache all service worker. It uses the strategy stale while revalidate. So there's a strategy where it serves you the cached content and then it updates the content on the background. So this doesn't save the network resources, but it helps you with speed and it looks that your application is running offline. This is the strategy that is used even in this site. So we have the service worker that is running on this side using this strategy, but it's a little bit more nuanced. It has more stuff in there, so we'll take a look at it in a minute. But these two service workers are just fine if you want your application to just work and you don't need to care much about what's happening, what gets sent for different parts of the website, or taking care of the notifications and stuff. You can just take one of these, put it in your website, introduce the manifest file. So this is just a plain JSON file. And suddenly you have an application that can be installed. We'll take a look at it now. So, how do you install the application? We are running this website in a browser. This is Microsoft Edge. So if you click here, you can go to the apps section and click install the application. So what this does is it creates an application. So you can see, okay, cache of the Windows failed me, but you can see that the application is here. It's for the user, it looks like a normal application. When you run it, it shows in this kind of a window. So it shows an application that has an icon. It's launched separately, so it's not just a tab in the browser. So it doesn't open in the browser that is already running. It runs as a separate application. It shows you some information about which browser you are running in. If the user wants to take a look at it, then they can. But the application can just work. It can work offline. There is no big issue with it. The color of the toolbar is set by the application. So it's similar to the yellow that I have directly in the browser. So you can see that there is a slight difference in there. But this color is actually coming from the manifest file. So it's the theme color that is set for your application. So you can have the application set the color of the toolbar. This is the most easy use case. So we can again, let's uninstall. We can uninstall the application so that it doesn't run in the application as is. This should uninstall it, and now I'm again back in the browser. If I took a look at the mobile device, so let's see how this looks on phone. So this is my phone connected, and we can take a look at this site in, let's say, Chrome. I already have the app installed. If I didn't have it installed, you would see a prompt to install the application once you visit the website and the browser sees that there is a manifest file, there is a service worker registered, it's running on HTTPS and so on. A prompt shows in the browser that asks you, okay, do you want to install this as an application? You can just click it, set install, and it installs this site as an application. You can see that there are some other items that than those that are showing here. We'll see why in a minute. Once it gets installed, it looks just like this. So there is an icon, there is a name of the application. When I run it, it runs in full screen. I can do login. There's some issue right now, probably with the internet, so let me just restart my connection and run it again. Yeah, let's log in. So I can run it this way. You can see that there is no Chrome shown, there are no toolbars, there is nothing happening. So the user actually sees this as a mobile application. The user doesn't need to know that this is running in a web browser, that this is a website. So this way the application has a logo, it has a name, it doesn't show the browser in any way, and when you run it, it runs full screen. So it's quite nice experience for the user. Here you can see an example from another browser. This is installed from Opera. So when I run it, it again runs as a full screen application. It behaves like an application. It can run in the background. It can work in offline mode. But in Opera, the installed application shows up as this. So you can see the application logo, but you can also see the browser icon in here. So it depends for a user where they install it from. If they install it from the browser, it can behave a bit differently based on what browser they chose to install the application. We'll take a look at installing it from the App Store / Google Play Store in a few minutes. So these are the applications that got installed from the browser on the cell phone. You could see that they ran as a full screen application with no showing of, okay, we are running in the browser. And they can work offline, and they are just fine. From the user's perspective, they don't even need to know that it's a website. In fact, it's an actual website, so it's running a full screen browser basically. So it's nothing special, no special technology that is hosting the application and that is trying to interfere with it. It's just a full screen browser basically for you as a developer. You can use all the capabilities of the modern browser, so you don't need to work with something like Apache Cordova or PhoneGap or stuff. And you can just rely on what is available in the browsers, and the user can even choose which browser they install it from, so they can have the experience that they want. All right, let's take a look at some more slides now. We'll get back to the demo in a minute. So here are the screens that our application has. So you can see the 3 screens that are dynamic, that actually work with some data and show and use and save the data into the database and so on. And then there is the offline screen, which is just an HTML file. What we are going to talk about further is something called Trusted Web Activities, which is a way to host the application and to have a easy application to install from Android. So this is what works for Google Play Store. This is an Android-only technology, but it's a quite nice way to distribute your application, and we'll take a look at how you can package your application in this way and distribute it to your users. The trusted part of the name suggests that this is a technique that you can use to tell that you are both the web developer, that you own the website that is running in there, and that you are the app developer, so that you created the actual application. You need to upload a file to your web server so that you can connect them with your application, and so that the application knows that, okay, this is the actual server that I was created for, and it's not showing some scam content. It's called a digital asset links file, and this changes how your application gets rendered. So let's take a look at it. When I take a look at my phone, there is this application that got installed as an APK. So this is an actual Android application. When I run it, it runs in this mode. So there is kind of a toolbar which shows me which browser I'm running in. So you can see that this very closely resembles the thing that I was running on in the browser on desktop. So here the user can see that, oh, okay, this is some website, what's going on? And it's running in the browser. So this is kind of a weird experience for the user. This is because I don't have the asset links file in there. So when I kill the application and I go to my server, I need to connect to the server where the application is running. So let's take a look. Oh, wow, okay. That's not ideal. Let's see. It should be running, absolutely. Okay, that's better. So let's log in, and let's take a look at our files and add the asset links file in there. So now I'm looking at the files of our web application, and in the www root folder, I can create a folder called well known, and I can create a file called asset links.json, and let's fill the file with actual data. So I have the file in here, and let's just update this over here. So now when I approach this URL, so when I get to the .well-known asset links.json, the server serves this file. It contains the fingerprint that got generated from the certificate used to sign the application. So this is how you connect the dots. This is how you connect that you are the application owner and you are the website owner. You sign the application with your certificate, and then you get created this string, which you then upload to your server so that it matches the application certificate. So now when we take a look at the application, when we run it again, you can see that it's the same application, and suddenly the toolbar is not here. So this way the browser knows that, okay, this application is the real deal. The website that I'm showing is connected to this app, and I can show it just as a regular application. The user can rely on the developer that it's his or her work. So let's see what to do further with your application. This is a link where we can take a look at some way to create the asset links file. It's from Google, so this is their documentation on how to get this done. We've seen the Chrome developer tools, so just to quickly repeat, you can see the stuff that your application uses and your application has set up. So the manifest file, the service workers, you can take a look at the storage. And furthermore, what you can do is that you can run an audit on your file, on your website. Let's take a look at it now. So we have our website running, and when we take a look into the DevTools, we can take a look at the audits toolbar or the tab and run an actual audit for the progressive web app. This checks the capabilities of your web app and it shows what you have set up, what you don't have set up. So what you need in order to be installable, in order to show up as an application when the browser hits the website, then you want the pop-up and you want the user to be able to install it, you just need these three things. You need to use HTTPS, you need to have a service worker installed, and you need to have a web app manifest file, which has all the properties that are needed for the application to be installed. So these are the only three things that you need. But there are some recommendations in here that will help you with getting your SEO for the website up and getting better recognition as a website and even better functionality so that it works properly on iOS and so on. So you can check in here what other things you could set up to get your application in a better state. This can help you. The other tool that can help you a lot with application development, with PWA development, is something called PWA Builder, which is a website created by Microsoft. You can also check your capabilities here, so you can run another audit so that you know that your application is okay. You can have some service workers that are already prepared and you just copy paste them into your application. So this site helps you with setting up your whole PWA experience. You can add additional features from the website, and you can even generate the packages that you can submit to the different stores. You can see that you can generate an Android application package, an application for Windows 10, or a direct package that you can upload. You can create a macOS project, so this can even create macOS application, and a Samsung package that can be used for getting installed from the Samsung stores for example, for their TVs. You can find the application here or the website. So let's take a quick look at what you can find there. So you start by entering an URL of your website so that it has something to look at and it can say whether your application is already ready or whether you need to add some things in there. You can see that this site is pretty much okay. There is just one slight modification that the PWA builder suggests, but it will run just fine. You can click the Build My PWA button in here, and here you can see all the different operating systems that are supported that you can create an application for. Let's go a step back and explore these options. When you take a look at your manifest file, here is quite a nice visual representation. You can upload all the properties in here, you can set it up, and it will generate your file so you can download it from here. So imagine that you come to this site and your application or website is not set up in any way for the PWA. You can get the manifest from here quite easily. Furthermore, if you take a look at this section, the Choose Service Worker section, you can see a bunch of service workers prepared for your application, and you can see that, for example, the offline page service worker is something that I got from this site. So you can just copy and paste it into your code. This is the code for the service worker. This is the code that you need in order to register the service worker for our website. So you put this in your site, and you can choose which one you prefer. So there are already some already prepared options in here. Okay, what about the Android application? As I said, you can download the pre-built package directly from the PWA builder. So this is the first option that you can use. I can say that I don't really like this option because I don't have many ways if I want to interfere with what the PWA builder creates. So there is just an APK that I download, the security keys come with it, and I can upload it directly to the Google Play Store, but I can't do something if I needed to. Furthermore, you can create a whole new project in Android Studio and set the whole thing up. The third option that I have here is that you can download the already made TWA Android Studio project. So it already works with the trusted web activities stuff, and it's basically a stop for your application. And you just modify a few things. Here is a link to a repository that I used for creating the sample for this demo, and here's a YouTube video where the developer shows you what you need to modify in the stuff. So when we take a quick look at it, I'm not a Java developer, I'm not very familiar with Android Studio, so this way I would actually struggle if I needed to create this on my own, but it's a very simple code. There are just a few Gradle things in here, and just a very little setup that you need to do. And you just enter a few things. You enter the site URL for your site, you change the name of your application, so when it gets installed that this is your application, and you change the icons for the application, of course, and you can create your APK from here. So it's quite easy. There are very few things that you need to change in this project to get your application up and running. So let's talk about iOS. I haven't mentioned iOS much until now. In the PWA builder, you could see that iOS is missing from there, so you cannot just generate an application for iOS from the PWA builder. So what you can do, you can have the user run your application from the browser or install it from the browser. Here is just one small caveat. When the browser shows your website, it doesn't prompt the user to install it. They can install it if they know how to. There is an option in the menu, but it's on the second screen, so they need to open the menu, they need to slide through the menu, and just then they get to the Add to Home screen button. But you can create a custom prompt that will show the users, okay, this can be installed as an app, this is an application, and if you click it, then we'll show you the system prompt and you get the install button and so on. So it can be done. It's quite easy. You can, even on the PWA builder side, you can find the script that you just put into your website and it renders the installation prompt. And it's a supported scenario, so it's supported both in Safari and Chrome and so on. So you can install it as an iOS application. It actually installs with an icon, it runs separately. The whole deal that I showed you on an Android phone runs also on iOS, so that's fine. If you want to go the App Store route, there is slightly bigger issue. Well, not slightly, this is quite an issue. You can use Apache Cordova for hosting the application. You could use it until quite recently, until the April of 2020, when the UI web view was kind of deprecated. Well, it was deprecated even before, but right now you cannot submit new applications using the UI web view, and the tools and libraries that are used for hosting PWA in Apache Cordova are a bit outdated, so they still use UI web view. There's the component for showing web views in an application. It got replaced by something called WK web view, but this is not currently in a great state in Cordova. In Cordova, actually, it's okay, but with the plugins that are supposed to be used for hosting the PWAs, it's not yet supported. We are trying to get this fixed. We are trying to look at some alternatives to this, or to get it working with WK WebView with Cordova, but currently we haven't yet figured it out. So we have a few applications of our clients running out there which are in the App Store, which use Cordova, and they run just fine. But right now it's impossible to use this technology to get into the App Store. So this is a bit of an issue which we will definitely work at fixing, but right now it's in this state, so I need to tell you this in order to have the complete information for you. So before we let's see some real-world applications that use this technology, and then we'll go back to the demo and take a look at how the notifications work and take a look at our custom service worker. So these are some types of applications that are built with PWA technologies. Not all of them use all the techniques. Not all of them are in the store as PWAs. Some of them have the website set up as a PWA, so when you visit them from your mobile device, you can install them and use them as an application. But some of them have another version of the site or of the application in the App Store or the Google Play Store. Twitter is a nice example of something that actually uses PWA. It has its own way of doing this. It did this before it was cool. So it did it before all the trusted web activity stuff and so on. So they needed to handle this in their own way. So they are actually hosting it somehow in the application. But it works as an offline it's as a PWA application. So this is a nice sample of this. But you can see that other applications use these technologies as well, either to help with their website, so that they are using a service worker to cache some stuff, or even to run as applications and have it installed this way. So, as I said, let's take a look at our code a bit further. So, when we take a look in the resources folder, we can see some scripts in there. I used TypeScript for creating this. The scripts are quite easy, so there's not much code in there, but I didn't want to mess with the libraries in JavaScript, and so I set up the TypeScript in here and the Webpack for building this. So let's take a look at the service worker first. Here, in the service worker, excuse me, you can see that this is a bit more code than was there in the already prepared service worker, but it's still quite okay. You can see some stuff that is connected to the notifications. We'll take a look at it in a bit. And you can see the stuff that handles the strategies for caching and for requests handling and so on. So here are some setup for the caches, for how the caches will be named. And this is the pre-cache method that gets called and caches all the stuff that needs to be handled offline. So you can see that it caches the HTML file for the offline page, it caches the logo, and it caches the root of the website. This actually shouldn't be here. I was experimenting with something, so I'll just remove this. What I want to do is when the service worker gets installed, I want to cache all the files that need to be there in order for the application to work. So either you get in the application to an offline page, so then we will display the offline page, or you launch the application. So when the user is offline and they launch the application, we don't want them to get some bad prompt from the browser that they are offline. We want to show them something. So this way we will show them the home screen. If we don't have any dynamic content on the home screen, we can just cache it and save it. You can set the cache to expire in some way, so it will update if the user is online. But this way, when the user installs their application, they don't use it for a couple of days, and then they are offline, run it, they will see at least something. They will see the home screen, and when they click some link, they will see the offline page. Furthermore, this is one endpoint that gets registered as a network-only resource. So we'll see why. And the rest of the application gets handled by the stale while revalidate caching strategy. So this way we can see that the expiration is set to 24 hours basically. So the files get cached for 24 hours and you can do this strategy for the rest of the site, or you can, this is a regular expression, so you can set it up to handle just some part of your website, just some routes or the whole thing, depends on you. The last thing that is in here is setting the cache handler. So if all this fails, if it's not cached in this, if the network fails, if the stale bar revalidate strategy doesn't go through, so it's not in the cache and the network is offline, it will fall back to this handler, which serves the offline fallback page. So this is just the handler that will take a look at if the request wants an actual document, so that you are not responding with HTML to some post request or so, then it will return the offline fallback page. So this way, when everything fails, you will get to the offline fallback page. Alright, so this is quite easy. What more is in here? We can take a look at the master page where the script registration happens. So here is just a very short JavaScript which registers the service worker. It checks if the service worker is supported in the browser. I'm not checking for if it's already registered. It won't actually register it again unless something changes in the service worker. So it checks for the hash of the service worker. If something changes in the file, it will run a new installation, but until something changes, it will just stay with the old service worker and you are fine to go. So this is just a very short script. You can just change the URL to test another service worker. So if I change this URL on the server to the offline page JavaScript file, it would register the file in there and it would use that as a service worker. So this can be changed quite easily. All right, what else is there? The application file, which has some interesting code in here. First of all, this is something that we haven't shown yet. So let's take a look at how our application behaves when it's offline. So we can see that there is some prompt that, oh, you're offline. how this happens? It's quite easy. It's a very easy code. There are actually two ways in here that are handling this offline state so that we could show something, some demo of the network only resource. One way, the easier one, and that's probably the one that you will use, is to hook up an event listener to the window for the events online and offline. So this is when the user goes online or offline, this gets called. And what gets called is, okay, we are reaching into our view model. So this way, it's a bit of a hack, let's say, because you are relying on the property to be there. So if we take a look at our view model, there is a property called isPageOffline. So you can see this in C#. You can do whatever you want with it. And how to reach it from JavaScript, you can do it this way. So you can just go to the view model within the .vvm hierarchy of objects, and you can set its value. So when we are online, I set it to false so that it doesn't show the offline page notification. When we are offline, I set it to true so that it does show up. If we take a look into the site, so this is the to-do list page, we can see that this is the section that gets shown or hidden based on the isPageOffline boolean. So this is what gets set. You can set it directly from JavaScript. As you can see, there is no network request, there is no postback happening. So this way you can just set the value and it shows up. So right now the site is offline and it reacted to this. When I go back online, it gets hidden again. The other way to do this, which is about this, is that we are constantly checking if we can get a request sent to some URL. So this URL is a simple presenter in .vvm, so you can create your own presenter which just sets the status code and sends back the response. There is nothing happening in here, so not much chit chat going on, not much data exchange between the server and the client. But this request goes out every 10 seconds and it checks if it can get to the server. If it times out, so there is a timeout set up for 3 seconds. If it times out, it sets again the property to true so that it shows the state. If I didn't have this in here and went offline, it could take up to 13 seconds, so 10 seconds until it gets called and 3 seconds until it times out to show the actual offline state. But this is a quite nice way to handle if I can actually reach my server. If I don't trust the events from the web browser for some reason and I actually need to check if my server is responding, then you can do it this way. What's important about this is that in the service worker file, we have this network only strategy. If I didn't have this line of code in here, so it would look like this. The first time that it asks for the request for the URL, it would find out that, okay, it's not in the cache, so let's load it from the server and put it in the cache. So then the second time it asks for it, even if you're offline, it gets returned to you from the cache. So you wouldn't even know that your server is down because you would get it from the cache. The service worker on the background would have some issues with this. It would complain that, okay, I can't update this from the server, but it's already cached. It will be cached for 24 hours. So you're out of luck for checking for the offline state. So this is why there is the network only strategy used for this. Okay. What else we have in here is handling of notifications. So if you want notifications, here we use Firebase. We use Firebase for sending the notifications and for registering the devices or the browsers for the notifications. This is the initializing and asking for permissions. So here you initialize your messaging, Firebase messaging, and you set it so that you show which service worker is being used for handling the notifications when you're offline, when you're running in background, so when the application is not running. And here you ask for permissions, so if the user hasn't yet given you the permissions to allow notifications for this website, you ask them for getting the permissions and you save the token. Here again, how do we save the token? We again set it directly from the JavaScript to our property, which is again in the master page. So here we have the property that we save it to. And then once we log in, so this is where the user actually clicks the login button and gets redirected to the to-do list page. We check if the username is actually entered in there and if the token is fine, so that the user gave us permission to send them notifications. And if this is the case, then we save the token to our database. So that we know that this user has this token associated to them. User can have multiple tokens associated to them because they could open your application in different browsers, they could open it in different devices and so on. So this way you can register multiple devices, multiple browsers for your user. We'll see how the notification looks, and we will take a look at the notification in a bit. And after this, the user gets redirected to the item list page. So that's the page with all the items in there. What happens with the notifications? When we send the notifications to the user, to the browser, we want to somehow display them. So here is a way to handle the messages when the application is running. So when you have the site displayed and the notification comes in, the service worker won't get it or won't be able to show it as an actual notification as in the system. You could do this from the website, so you could handle it here and show it as a notification on your device. But here we are just showing it in the website. So we get the data from the notification, we get the title and the body from the notification that got sent to us, and we again set it to our .vvm properties. So let's take a look at this. There is a property called push notification content, and it has a title in there and a body. So this way we set the properties and we can show it somewhere. So if we took a look into the master page, we could see that there is a section where we are showing the push notification. So we are basically constantly showing it, just hiding or displaying it based on if there is a title in there. So we are checking if the title is not null, then this can be visible. And there is the title in there, the body, and a button to hide the notification or to clear the content. If we took a look at this, it just resets the notification content so that we can again fill it with data from the JavaScript file if we needed to do that. Furthermore, in the service worker, what we have in here is, again, we are setting up the messaging. So here you can see that the Firebase again gets set up and we get the messaging from there. And we set the background message handler to show the notification. So let's take a look at this in action. let's take a look at the site. We add a new to-do. And set the notification to some nice time. Let's say a minute from now in the future. Let's click the save button. And let's open it up also on the mobile phone. And let's see what happens now. So what handles the notifications is Azure function that is running and checks every minute if there is a notification and sends it to our devices. Okay, nope, that was a different notification. Okay, what actually happened in here? There might be some issue. Let's take a look again. The time looks okay. The difference between the current time and the time displayed here is because of UTC. So this discrepancy is because I'm 2 hours away from the UTC, but we are setting this as UTC time. So I might be locked out because I deleted the cache and the history. So let's try one more time. All right, so let's put it on 10:53 a.m., which should happen in about half a minute. And let's also reload it on the mobile device just to make sure. Okay, where is the mobile device? Here. So now the notification should show up also in the website here running, also in the mobile application, and we'll see if it works. Then it should even show up in our notification center. So we'll see what happens in a few seconds. Oh, and it didn't show up. Okay, so there's something broken in here. However, we can at least show that the Stelva revalidate strategy is making our website behave in a weird way. We can see that the finish item is in here. If I refresh, oh, suddenly this one appeared. If I click this and make it complete, reload the page, oh, it's not behaving as I expected. Now just it happens. So what we are seeing here, and you could see this also on the mobile devices, you are getting one item older than you actually want. So you are getting the HTML from the cache, and just then it gets updated. So this way you can see that this is not always what you want as for your users. You don't want them sometimes to get the older version. So this way you want to use different strategies for different parts of your website. If the part of your website doesn't make sense for caching, so there is some dynamic data, there is something showing up for the user, and you don't want them to see an older version of your website, you will use, for example, the network only or network first strategy, so that they get it directly from the server, and if something fails, they can get the cached version at least. But if you have some parts of your website that are fine for getting older response and updating on the background, then you can use the Stelva revalidate strategy. So this depends on which part of your site you want to have registered. But the main idea is that you don't need to really think about this while you're creating the website. You will create your website just as you are used to, and then you can add the service worker in there, add the app manifest in there, and you are good to go. The application can be installed, you can create the Android application, and so on. So the notification part didn't really work. I'm not exactly sure what happened in here. It worked just a few minutes before I started to do this demo. I tried it. So there might be some issue with the Azure function that is sending a notification or something else. The setup that is shown here should work, so there might be some caching issue or something with the token. The important thing is that once the service worker gets updated, so you install a new service worker, you get a new token from the Firebase messaging service. So every time you get a new service worker installed, you need to update this token on the server, because if you send it to the old token, nobody receives it. There is not a thing to show. Oh, it woke up, so suddenly the notification came in. I'm not sure why so late. Maybe the Azure function took a bit to load. But you can see that, okay, so here it displayed in the browser. Here it also displayed in the browser, the application is running. So this is the part where the app.js file handled it, and it showed it. It filled the property that was supposed to have the notification content in there, and showed the content accordingly, because the website is showing the notification when there is a title. So when the title got filled in there, this got shown up. I can close it this way, and if we take a look into the notification center, this is from the application that is installed there as an APK. So there is an application running, not running, the service worker is idle in the background, and it handled the notification and showed it in the notification center. Here in Windows, it didn't pop up because I have the application running, so it came to this website. If I closed it and set up another notification, it would actually pop up as a system notification in Windows just as well. So these are the two ways to handle the notification, and you can see that it depends on whether your application is running or not, but you can even you can set it up to show the system notification even from the running application, just so that we can see that you can handle it differently if the user is running your application actually. All right, so with this in mind, you could see that it's quite easy to create an app from your existing website. It's quite easy to set the tokens to just send it from the JavaScript back to .vvm and to set it to the server. And it's not much of a work if you just need to create a basic application from your existing website. So this way you can use the technologies that you already use, that you already know, the websites that you've already created, and make some nice applications from them, submit them to the stores, have your users install them from browsers, and so on. All right, so that's it from me. If you have any questions, feel free to ask. I will be here after the session, so to answer your questions. Okay, thank you for your attention.